Welcome to The Explainer. Today we're going to talk about something that's quietly changing, well, everything for AI. It's called the Model Context Protocol, or MCP, and it's basically the key to unlocking how AI interacts with the real world.
So let's just dive right in. What is the fundamental problem that MCP was even designed to solve? Well, for the longest time, even our most powerful AIs were kind of trapped.
Have you ever been there? You're trying to get your AI assistant to do something that feels simple, right? Like, hey, check this file on my desktop, or help me debug this issue that's spread across a few different projects. And it just can't. It's like it's this brilliant brain trapped in a box, completely blind to your actual personal world.
And the reason for that frustration? Well, it all comes down to a classic, messy software problem called the N by M integration problem. Just picture this. For every AI model, that's N, you have to build a totally custom one-off connection for every single tool or data source. That's M. It's chaos. It's like needing a different, unique, and super fragile adapter for every single thing you want to plug into your computer. Nothing talks to each other. It's just a complete mess.
So a situation like that, it just wasn't sustainable. Clearly, something had to change. The entire industry needed a way out of this chaos.
What everyone really needed was a universal standard, a single, reliable way to connect any AI to any tool. Think about it, right? We used to have a drawer full of random chargers for every old phone. Now, we pretty much just have USB-C. AI desperately needed its own version of that. And that's the perfect way to think about the Model Context Protocol. It's literally been called the USB-C port for AI. When Anthropic introduced it back in November 2024, that was the whole idea, to create that one universal connector that just works. So what is the Model Context Protocol, really? At its core, it's an open-source, standardized language. And here's the crucial part. It completely separates the AI's brain, its ability to reason and think, from the limbs, which are all the external tools and data sources. This is huge. It lets the AI focus on being smart, while all the other tools do the heavy lifting.
Okay, so how does this thing actually work under the hood? Let's get into the architecture of it all. It's actually a really elegant three-part system.
So you've got this three-tier architecture. First, there's the MCP host. Think of this as the AI's home base, like your VS Code or Claude Desktop. Then you have the MCP server. This is the thing the AI wants to talk to, a file system, a GitHub repository, whatever. And connecting them is the MCP client, which is basically a dedicated translator. So you've got the host, where the AI lives, the server with the data, and the client making sure they can all talk to each other seamlessly.
So let's walk through a simple request. You ask the AI to summarize a file. That prompt goes to the host. The host then says, a file request, and passes it to the right client. The client translates that into a structured command for the file system server. The server grabs the file content, sends it back to the client, which sends it back to the host, and finally, the AI gets the context it needs to give you that summary. It's a clean, logical flow.
And this whole language that they're speaking, it's built on three fundamental concepts, or what they call primitives. First, you've got tools. These are for doing things, like creating a Git branch or saving a file. Then you have resources. These are for reading things, getting context from a config file, for example. And finally, you have prompts, which are super interesting. They're like reusable instruction manuals for the AI, guiding it through complex, multi-step tasks. It's like a recipe that says, first, read this bug report, then find the right code, then suggest a fix. Really powerful stuff.
Okay, so this isn't just theory, right? This architecture has had a massive real-world impact. It's basically the foundation for what we now call agentic AI.
And when I say massive, I mean it. The growth has been absolutely explosive. At launch, there were maybe 100 MCP servers. By late 2025, over 16,000. That's just wild. It really shows you what happens when you create a powerful open standard. Suddenly, anyone can build a connector for their tool, and it just works with every AI. That's a classic network effect in action.
And this has huge implications for businesses. Think about it. People in finance, marketing, HR, they can now solve their own data problems just by asking questions in plain English. No more waiting for an engineer to write a complex query. You can just ask an AI agent, hey, pull the latest vendor emails, and bam, it's done. It's a massive productivity boost.
And for developers, oh man, it's an absolute game changer. Your AI assistant is no longer just a fancy autocomplete. It can be a real partner. It can trace a single bug across, say, 5 different microservices at the same time.
That's something that could take a human engineer days of painstaking work. Now, it happens in minutes.
But okay, there's a catch. When you connect your AI to thousands of tools, you run into a new problem. The AI's working memory, its context window, gets totally clogged up with descriptions of all those tools. So Anthropic came up with a really clever solution they call code mode.
And get this number. By switching to this code mode, where the AI only loads the tools it needs on demand, it reduces the token usage by a staggering 98.7%. That's insane. It means the agents are way faster, way cheaper to run, and can handle much, much more complex jobs.
So you might be thinking, how is this different from, say, ChatGPT's custom GPTs? And it really comes down to philosophy. MCP is an open, flexible framework. It's model agnostic, it works with any AI. It's like a professional set of Legos for developers to build whatever they want. Custom GPTs, on the other hand, are more like a pre-built, sealed toy. It works great, but it's locked into one company's ecosystem, and you don't have the same level of control.
Okay, so with all this incredible power comes some pretty big new challenges, especially when it comes to security, and it all points to a future that is way more connected.
I mean, think about it. Giving an AI direct access to your tools and data is, well, it's risky. That's why the protocol has to be super strict about security. We're talking about things like tool poisoning, where a good tool suddenly turns malicious, or prompt injection, where someone hides secret instructions to trick the AI. There's even something called a confused deputy attack, where you trick an AI that has legitimate permissions into doing something harmful for you. MCP has to guard against all of it.
And this is the really big takeaway here. MCP isn't just some niche developer tool. It's quickly becoming the fundamental plumbing for a whole new internet, a contextual web, where every piece of information, every tool, is natively accessible to AI.
And you don't have to take my word for it. The entire industry is getting on board. We're talking OpenAI, Google DeepMind, Microsoft, AWS. They've all come together under the Linux Foundation to form the Agentic AI Foundation. Their goal? To make sure MCP is a shared open standard for everyone. That's how you know this is a big deal. It's becoming critical infrastructure for the future of AI.
And what this all signals is a really fundamental shift in how we even think about AI. We're moving past the era of simple chatbots. We're now building truly autonomous collaborators. And in this new world, an AI's value isn't just about how smart it is in a vacuum. It's about how deeply it's connected to our world and our tools.
Which, of course, leaves us with one massive question to think about for the future. What actually happens when every AI can talk to everything? What kind of world does that create, with all its incredible possibilities and all its new challenges?